Our Capstone project is renewable energy. Let's start by understanding what a photovoltaic system, or a PV as we'll be calling them henceforth, is. PV systems use the sun's energy to make electricity. A PV system therefore eliminates or reduces the amount of electricity you purchase from your utility. The typical size of a residential PV system is 2 to 5 kilowatts. The other important consumer product we'll be looking at is the EV, or electric vehicle, which uses energy stored in its rechargeable batteries. These batteries can be recharged by common household electricity. Examples of EVs are Tesla Model S and Chevrolet Volt. Our Capstone objective is to create a data-driven predictive model of the impact of varying levels of EVs and PVs. From the perspective of an impact on utility distribution system operations, PVs and EVs represent the highest per instance impact of any new customer product since the introduction of air conditioners and clothes dryers. Our Capstone data is from Pecan Street, which is a Texas-based organization that provides data derived from voluntary participation of households from Texas, Colorado, and California. We analyze hourly power consumption of over 1,300 households during the peak and off-peak hours. Peak hours are defined by the Texas Power System Operator as 8 hours to 22 hours on Monday to Saturday. All the remaining hours are considered off-peak. Our house characteristics included in the dataset are location, building type, year of construction, total square footage, number of floors, presence of PV panels, and EVs. Our sample set of around 720 households, almost 69% live in single-family homes, followed by 25% living in apartments, 5% living in townhomes. 63% households have PVs, while only 13% have EVs. After our initial analysis on the types of houses and their adoption of solar panels, or PVs, and electric vehicles, or EVs, we conducted further analysis on power consumption of Pecan Street houses. The box and whisker plot here shows the ratio of power consumption from the grid during peak and off-peak hours, subject to the adoption of PV and EV. In comparing the average power consumption from the grid during peak hours, we observed that the presence of PVs significantly reduced the net grid consumption across all house types. Finally, we created a comprehensive interactive dashboard to provide a view of the power consumption of ratios and PV-EV adoption for different building types. For example, if we were to focus on people living in apartments, we see that none of them have adopted to PVs and EVs. While single-family homes may have adopted EVs and PVs, we also observe how this impacts the average power consumption.